Okay, so we have this question 4. Use a tree diagram to illustrate the sample space for the possible four-child families. Hence, determine the probability that a randomly chosen four-child family is A, or boys, and so forth. So I've drawn it up here. As you can see, this is a tree diagram. We have each event, which is the birth of the first child, the second child, the third child, and the fourth child. And we get a separation of the tree. Now, to work out the probability of getting any combination, we actually have to multiply the probability. Now we've got the probability of getting a girl would be a half, the probability of getting a boy would be a half. We assume that there's an equal probability for that. So to have all boys, we would have to be going along this path. So it would be a half, a half, a half, and a half. So the probability of that, the probability of 4 boys would be a half times a half times a half times a half, and that would be 1/16. And in actual fact, for each of these, any specific path, let me just take another one. Let me just take this path over here. If I went along there, say we had a girl, we had a boy, we had a girl, and a boy, the probability of getting in that would be a half times a half times a half times a half, which would be 1/16. So any path through this tree diagram will give you a value of 1/16, which is going to be useful later on. Okay, for B has exactly 2 boys. Now there are obviously different routes for getting exactly 2 boys, and we've actually got to basically add up the number of different routes to do that. So let's start at the top. This would be one route. If we had a girl, a boy, and a boy. So there's one. Now each of these 1 is 1/16 of a chance. So we've got that. We could have a girl, and then a boy, and then a girl, and then a boy. That would be another opportunity of doing it. We could get a girl, a boy, and then a girl. So there's another one. That would be all of those. We could get a boy, then we could get a girl, and then a boy. That would give me 2 boys. Or we could get a boy, and then we could get a girl and a girl. That would be another one, plus another one. So are there any more? I don't think so. I think that's it. Eh? So we could get a boy, girl, boy. Oh, here's another one. Yeah, a boy, girl, girl. There's another. So that's another one, plus another one. I think that's probably it. A boy and a boy. That's done. Okay. So how many different ways are there? There's 1, 2, 3, 4, 5, 6. So there's 6 ways, and each one is 1/16, so it's actually 6/16 would the probability of exactly 2 boys. Alright, and then more girls than boys. So we need again to look at all the possible routes for that, where we're going to have more more girls than boys. So let's do this one. This one, girl, there's 1. A girl, there's another. You've got 3, you've got 4, and you've got 3. All of these are girl, boy, girl. There's another one. Girl, boy, girl. You're getting 3 girls there, only 1 boy. You can't go that one. That will give 2 boys. Okay, then we get a boy. Then we get a girl. That's giving us 3 girls. And can we get any others? I think that's it. So that's 4 different ways. Each way is 1 out of 16, so it's actually 4 out of 16 chance of having more girls. The probability of getting more girls would be 4 out of 16. Okay, so that's that. So you can see it's relative. This was quite a complicated one. You would seldom be asked to do such a complicated one as this. Okay, thank you for that.